In this video, we'll look at spanning tree protocol, and we'll explain how it helps to prevent switching loops in an Ethernet network. So here we see a diagram where we've got one physical or virtual machine, and it doesn't matter. These could be physical switches, these could be virtual switches. They both basically operate the same way. So I've got some machine here that's connected to either a physical or a virtual switch. And let's say that that machine generates some sort of broadcast traffic, like, for example, an ARP request. Well, when my switch receives that broadcast traffic, what it's going to do is it's going to flood it out every single port on that layer 2 network, including this port here that connects to another physical or virtual switch. So when that broadcast is received by this other switch, it'll go through the same process. It'll flood it out all ports, even ports that connect to other network devices. And you can probably see where I'm going with this now, is that what's going to happen is that frame is going to eventually end up getting flooded back to that same switch if our switches are connected in a topology that creates this loop. And this will essentially result in an endless loop where the traffic just goes around and around and around and around and eventually brings my network to a screeching halt. So switching loops are definitely not a good thing, right? We want to make sure that we have a loop-free topology. And Ethernet frames are not configured with a time to live either. So an IP packet might be configured with the time to live, but that time to live is only for hops across routers. So if an Ethernet frame comes in, hits 1, 2, 3, 4, 5, 6, 7, and so on and so forth, there's no limit to the number of hops that that traffic can take. There's no time to live defined. So the way that we can resolve this is by enabling what's called spanning tree protocol. And what spanning tree does is it guarantees a loop-free topology. So how does it do this? Because we might have a physical loop in our network. How does spanning tree prevent a switching loop from occurring? Well, what it basically does is it'll detect these loops in the physical network, and it will pick certain connections to block. It'll put certain ports in the blocking state, breaking up those loops. So now when my broadcast comes from this machine, it flows out, it hits this physical switch, it hits this switch, and that's where it stops. This port is blocked. And so therefore, the broadcast stops there and the loop is broken. Right, so spanning tree does a great job of automatically finding these loops, blocking the appropriate ports, and ensuring that we don't have these broadcast storms. But it does so at a cost. The network connection that we X'd out here, this network connection is not usable now. So we've lost some bandwidth as a result of blocking certain ports. Right? So spanning tree definitely comes with a cost. But the benefit in most cases outweighs the bandwidth loss. Because if we do have those layer 2 switching loops in our environment, it's just a matter of time before the network comes to a screeching halt. So that's the purpose of spanning tree. Now, a few things that I just want to mention specific to configuration with vSphere. If you're connecting a physical switch to an ESXi host, so let's say here's my ESXi host and I'm connecting a physical switch to that ESXi host. Well, in that case, we want to enable a special mode of spanning tree, port fast. Now, what port fast does is this. For all of these ports on my physical switches, they have to go through a certain process. Right? When I connect up a physical port, basically spanning tree needs to check and validate that this port is not creating a switching loop, right? And if it is going to create a switching loop, it'll get blocked. And that takes a little time. This is what we call spanning tree convergence, where the switches agree on the topology and the appropriate ports are blocked. We don't need that to happen on the ports that we connect to our ESXi hosts. So we'll configure those ports in a special mode called port fast that'll skip all of those spanning tree states, and the port will come up more quickly.